mathematical. Okay. Now in the previous session, we just see the mathematical analysis of open loop control system, and from that transfer function, and from that one important parameter which we are finding is type. Now in the same thing here, then we have another control system, therefore the same thing here also we'll see. Now closed loop control system, now we know that from here then we will see the mathematical analysis. From this mathematical analysis also we will find one important parameter. What is that parameter? Now you just recollect your previous class. Now previous session, basics of control system, previously open loop control system, mathematical analysis of open loop control system. Now from that open loop control system, what is the parameter you are getting? You are getting type as a parameter. Now in the same thing, control system, closed loop control system, mathematical analysis of closed loop control system, and what is the parameter we are revealing finally? This parameter we will see. Okay. Now before that we will see the closed loop control system mathematical analysis also. Now what is the closed loop control system block diagram? You know that the closed loop control system block diagram, reference input, comparator, reference input, comparator, controller, processor. Now this is feedback network. Now this is controlled output. Now see here, this we know that, and this is error signal. Now this is a mathematically equivalent model of closed loop control system. This is the closed loop control system. Now see here, this is reference input represented by R of t. Now this is controller whose gain is G1. This is processor whose gain is G2, which we already assumed, and this is the controller and processor, the forward path gain G1, G2, which is equal to G of t, which is nothing but forward path gain. and this is the feedback network, and this feedback network is also having some gain h of t, and this is the controlled output represented by some c of t. Now see here, reference input represented by r of t, error signal is represented by e of t, error signal is represented by e of t, controller gain is g1, processor gain is g2, overall gain is g1 and g2, which is g of t, forward path gain, and feedback network gain h of t, and controlled output is c of t. Now this we know that this is the block diagram of closed loop control system, but now we want a mathematical equivalent model. What is a mathematical equivalent model of this closed loop control system, which we can identify by applying the transfer function? Then if you apply the transfer function, now see the difference. The Laplace transformation of r of t, which is nothing but r of s Now, the Laplace transformation of forward path gain g of t is g of s. The Laplace transformation of c of t is c of s. The Laplace transformation of feedback network gain h of t is h of s. Now, this feedback network will bring processed output. You know that. This feedback network will bring processing stage output. Therefore, this is the feedback network output, which is nothing but the processed output, which is nothing but c of s into h of s. Now, this is the error signal e of s. Now, see here. Now, this is the mathematical equivalent model of closed loop control system. Now, once if you have a closed loop control system mathematical equivalent model, you can easily find the transfer function. Now, what is the closed loop control system transfer function? Now we will see. Now, what is the controlled output? What is the controlled output? The controlled output c of s, the controlled output c of s, which is equal to g of s into e of s. Now, what is the error signal? The error signal e of s, which is equal to r of s minus c of s into h of s. The error signal e of s, which is equal to r of s minus c of s into h of s. If I substitute that is here, e of s into here. Now, the controlled output c of s, which is equal to g of s into, what is e of s? R of s minus c of s into h of s. Therefore, now see here, the controlled output c of s, which is equal to g of s into r of s minus g of s into h of s into c of s. Now, if I take this c of s as a common, if I take this c of s and this c of s a common, 1 plus g of s into h of s, which is equal to g of s into r of s. Now, finally, we have a relation between c of s by r of s, because the transfer function definition is nothing but the Laplace transformation of output by Laplace transformation of input. Now, see here, what is the transfer function? The Laplace transformation of output, C of S, this is output, C of S, input, R of S, because this is controlled output, C of T, reference input, R of T. Therefore, the Laplace transformation of C of S by Laplace transformation of input, R of S, which is nothing but transfer function. The Laplace transformation of output C of S by the Laplace transformation of input R of S, C of S by R of S, which is equal to G of S by 1 plus G of S into H of S. This is closed loop control system transfer function. Then you tell me what is the difference you observed. What is the transfer function you can get in the case of open loop control system? In the case of open loop control system, you can get only G of S. Yes, in the open loop control system, you can get only G of S because there is no feedback path gain in the case of open loop control system. But here, there is a feedback network, there is a feedback path gain. Therefore, now you can get the feedback path term also comes into the picture of transfer function. This is the closed loop control system transfer function, and this is the closed loop control system mathematical equivalent model. Now, you can also say that this is the closed loop control system transfer function, which is also consisting of control system parameters. And I am already saying that in the open loop control system itself, I am saying the control system, any control system whose parameters, whose behavior is depends upon the control system parameters. One is control system gain, another one is control system time constant. Then you take this is a block diagram and mathematically equivalent model, and finally transfer function. Now see here, now what is the closed loop control system transfer function? Now this is the closed loop control system transfer function. Laplace transformation of output by Laplace transformation of input, which is equal to G of S by 1 plus G of S into H of S, which is equal to, now this is also a polynomial which is a function of S, K into 1 plus ST1 into 1 plus ST2 and so on by S power n into 1 plus STA into 1 plus STB and so on. Now see here, now this is a function of S, therefore I can write in terms of S. This is a polynomial, and which we already know that K is a control system gain where T1, T2, TA, TB and so on, which is nothing but T is control system time constant, because what I am saying is any control system behavior, whether the control system response, analysis or anything, is depends upon only two parameters, control system gain and control system time constant. That's what I am. But what is here? This is closed loop control system, which is called as closed loop control system gain and which is called as closed loop control system time constant. That is only different. Now whether it is a open loop control system or closed loop control system, that control system behavior is depends upon the control system gain and control system time constant. Therefore, now we can say like this. Now this is the numerator polynomial and this is the denominator polynomial. Therefore, you know that the numerator polynomial roots are called as zeros and the denominator polynomial roots are called as poles. But this is which control system? Closed loop control system. Therefore, this is called as closed loop zeros and this is called as closed loop poles. That is the only difference. The definition and everything will be same. All the numerator polynomial roots are called as zeros. All the denominator polynomial roots are called as poles. Therefore, but this is a closed loop control system. Therefore, this is closed loop zero and this is closed loop pole. Therefore, now this is K is a closed loop control system gain where this T1, T2, TA all these things are closed loop control system time constants. Now you just compare this one with the previous session. In the open loop control system, what we are doing? Same block diagram, mathematically equivalent model, transfer function, and from the transfer functions we can find one important parameter. What is that? Type. Now in the same thing, now this is the closed loop control system, block diagram, mathematically equivalent model, transfer function. Then what type of parameter which we are getting here also we will see. Now before that, now see here, this is the denominator polynomial. What is the denominator polynomial? The denominator polynomial, which is nothing but 1 plus g of s h of s is equal to 0. This is the denominator polynomial of a closed loop control system. This is the denominator polynomial of a closed loop control system. The denominator polynomial of a closed loop control system is called as characteristic equation. Now see here, the denominator polynomial of a closed loop control system is called as characteristic equation. Therefore, this is the characteristic equation and this is the denominator polynomial of a closed loop control system. This is the first point. Then another point also we have to identify. This is the first point. The denominator polynomial of a closed loop control system is called as characteristic equation. The second point what I am saying is the roots of characteristic equation. The roots of characteristic equation. What are the roots? The roots of, this is the denominator polynomial. The denominator polynomial roots are called as what? Closed loop poles. Therefore, the roots of characteristic equation is nothing but closed loop poles. So this is characteristic equation is called as the denominator polynomial of a closed loop control system is called as characteristic equation, and the second point is the characteristic equation roots. The characteristic equation roots is nothing but closed loop poles. So is important. What is characteristic equation? The denominator polynomial roots The denominator polynomial is called as characteristic equation. What is there in the characteristic equation? The characteristic equation consisting of closed loop poles, because the denominator polynomial is totally related with closed loop poles. The numerator polynomial is denoted with zeros. Therefore, the characteristic equation is the denominator polynomial. The denominator polynomial roots is nothing but closed loop poles. Therefore, the characteristic equation roots are nothing but closed loop poles only. Take this one. And one more thing also we have to be identified. Now the denominator polynomial of a closed loop control system, which we call as characteristic equation. Why this is called as characteristic equation? What is the meaning of characteristic equation? Once you have the diode VI characteristics, then you can understand the behavior of the diode or not. In the same thing here is also, once we have a characteristic equation, the characteristic equation will give characteristics. The characteristic equation will give behavior. The characteristic equation will give complete analysis. Then yes, that is the reason why this is called as characteristic equation. If that statement is correct, if that statement is true, what is there in the characteristic equation? The characteristic equation is nothing but closed loop poles. What is the meaning of that? You just link this one. The denominator polynomial roots are called as, the denominator polynomial is called as characteristic equation. What is there in the characteristic equation? The characteristic equation is nothing but closed loop poles. Therefore, this closed loop poles, which is very important because that fellow is only gives the characteristics. That closed loop poles only will give the characteristics. That closed loop poles only will give the complete analysis. That closed loop poles only will give the complete behavior. Sir, is that statement is true? If there is no need to by heart, then our subject itself is showing all these things. Therefore, we will see. Very soon we will see the characteristic equation means what. What is a closed loop pole? The closed loop poles will give the total characteristics of a control system or not. You have an experience, not a problem. Okay. Therefore, we'll take one small example, and what should be the parameter is coming from the closed loop control system definition, transfer function. We will see what is the parameter you are identified from the open loop transfer function. What is the parameter you are getting in the open loop transfer function? In the open loop transfer function, you are finding one important parameter is type. In the same manner, what is the parameter should be identified in this particular closed loop control system concept also we will see. So this is a closed loop control system. Let us take one small example. We'll take one example here. This is example. Now closed loop control system transfer function C of S by R of S, which is equal to G of S by 1 plus G of S into H of S, which is equal to S plus 1 by S plus 2 into S plus 3. Let us take one small example. Now this is simplified further. S plus 1 by S square plus 5S plus 6. This is numerator polynomial. This is denominator polynomial. this is closed loop zeros, and this is closed loop poles. Now one small example I am taking, one simple trans function, closed loop control system trans function, numerator polynomial, denominator polynomial. Now you tell me how many number of closed loop poles? How many number of closed loop poles? How many number of closed loop poles here? How many closed loop pole? S plus 2 equals 0, S equal to plus 3 equals 0, S equal to minus 3. How many closed loop poles? Denominator polynomial roots are called as closed loop poles. So the number of closed loop poles are 2 here. And what is the characteristic equation? The highest power, this is the characteristic equation, right? Now, what is highest power in the characteristic equation? The highest power in the characteristic equation. The highest power in the characteristic equation is 2. Now, what is the characteristic equation? 1 plus g of s h of s equal to 0, which is nothing but s square plus 5s plus 6 equal to 0. Now, this is the characteristic equation. The highest power in the characteristic equation is s square. This is the characteristic equation. What is the highest power in the characteristic equation? Is 2. Therefore, the highest power in the characteristic equation is 2, and the number of closed loop poles are 2. Therefore, then if you observe here, now you forget about these 2 and these 2, all these things. Now, this is the definition of order of the control system. This is order of the control system definition. What is the order of the control system? The order of the control system is nothing but this is order of the control system. What is the order of the control system? The order of the control system is the number of closed loop poles is nothing but order. The highest power in the denominator polynomial, the number of closed loop poles is nothing but order. The highest power in the characteristic equation is nothing but the order. Yes, that's what I'm saying. The characteristic equation consisting of closed loop poles, there are 2 closed loop poles, therefore order is 2. There are 2 closed loop poles, therefore highest power is 2. If there are 3 closed loop poles, the highest power is 3, order is also 3. This is the order of the control system. Now this is the important parameter which is you are getting, which is nothing but order. Now what is the parameter we are getting in the open loop control system? In the open loop control system, we are getting type. In the closed loop control system, we are getting order. Now, this is 2 important parameters which are very important. One is type, now another one is order. You just see these 2 differences. Type is the parameter which you are getting from the open loop control system. Order is the parameter which you are getting from the characteristic equation, and that characteristic equation is nothing but the property of closed loop control system. Take this one. This is order definition, and one important parameter you are getting type, and in the open loop another important parameter you are getting order. Therefore, first you take this. Then, now up to this particular stage, then what we are studied, what we are having, what are the parameters we are having. Then we will see the open loop control system, closed loop control system, differences, definitions, mathematical equivalent model, transfer functions. From there, then we will see the poles definition, zeros definition, and another two important parameters, type, order. Then if I say a single word, type, order, pole, zero. If you understand these four parameters, definition of zeros, definition of poles, definition of type, definition of order. If you understand these four parameters, then I think nothing is there in the control system. Once if you understand these four parameters, then throughout our subject you can easily understand, because the total subject depends upon the system parameters. The system parameters are nothing but gain and time constant. Those are depends upon the zeros and poles. From there you can get one important parameters, type in open loop and order in closed loop. Therefore, if you understand these four parameters, then our subject, which is very simple and you can easily understand. Then that's what from this particular basic portion, then we will solve the previous GATE questions. Whatever the questions which we have solved in the classroom, which is nothing but all are the previous GATE 1 mark and 2 marks questions in the previous GATE examinations only, such that you can understand how the questions he is asked in the GATE examination. Now how much we are able to solve, then how much basics which we are having, such that you can easily cross check and you can easily understand. Okay, therefore we will solve the basic questions in the previous GATE examination what is given. Now this is question number 1. This is question number 1 in our workbook. This is question number 1 from the basics of the control system. That is question number 1. What is the question number 1? By considering the following closed loop control system, find type and order. What is the question he is giving? By considering the following closed loop control system transfer function, what is given to you? C of S by R of S, which is equal to 1 by S plus 1. This is the closed loop control system, question number 1 in your handbook, workbook. By considering the closed loop control system transfer function, he is asking to find type and order, Then see here, this is closed loop control system transfer function and he is asking to find type and order, which is very simple question. Is there any poles at origin? No, there is no poles at origin. Therefore, there is no poles at origin. Therefore, type, which is equal to 1. And what is highest power in the denominator polynomial? Highest power in the denominator polynomial is 1. Therefore, order, which is equal to 1. Type is, there is no poles at origin in open loop control system. There is no poles at origin here. Therefore, type is 0. And 1 highest power in the denominator polynomial is 1. The highest power in the denominator polynomial is 1. Order equal to 1. Therefore, then type is 0, order equal to 1, which is very simple question or not, because you know that the number of poles at origin, therefore type the highest power in the denominator polynomial, which is equal to order. This is previous GATE 1 mark question. This is previous GATE examination 1 mark question. Then how many marks you are getting? All of you are getting how many marks? 1 mark. You are thinking, but this is 100% wrong answer. This is a wrong answer. But definitely the option is type 0 and order 1, which is a wrong answer. Means what? Why this is wrong, sir? We are doing the same definition, whatever the definition you are saying, we are following that the number of poles at origin is 0, therefore type is 0. Then the highest power in the denominator polynomial is nothing but order. Yes, but this is a wrong answer. This is the wrong option. If you choose this option, you will lose your marks. Okay, this is the wrong option. This is the wrong option, which means that you are not perfect at the basic definition. Then number of poles at origin is called as type. Who will give that statement? I am not giving that statement, and just check out your notes, and I am not giving that particular statement. The number of poles at origin, that statement I am not mentioning, that statement I am not giving. Then you see your class notes also, then it is not there. So what is the problem here? You are where did you do the mistake here? This is the mistake. What is the mistake? We will rectify that. Now see here, what is given? What is given? By considering the closed loop control system. This is the closed loop control system transfer function. What is the closed loop control system transfer function? That is the closed loop control system transfer function. So what is the closed loop control system transfer function? The closed loop control system transfer function, generally you are represented by Laplace transformation of output to the Laplace transformation of input, which is nothing but, this is the closed loop control system transfer function, which is nothing but C of S by R of S, which is equal to G of S by 1 plus G of S into H of S. This is the closed loop control system transfer function, which is equal to 1 divided by S plus 1. Because in the question it is mentioned, this is the closed loop control system transfer function. Without the second thought, this is closed loop control system. The denominator polynomial is called characteristic equation. What is the highest power in the characteristic equation? The highest power in the characteristic equation is 1. Therefore, what is order? Then without any doubt, therefore order equal to 1. Because how many closed loop poles? 1 closed loop pole. Where is 1 closed loop pole? S plus 1 equal 0. S equal to minus 1. This is the closed loop pole. This is the closed loop pole. This is the closed loop pole, and highest power in the denominator polynomial. The highest power in the denominator polynomial is 1 and order equal to 1 and 1 closed loop pole. Therefore, no doubt here is also order 1. Yes, this is also order 1. But now in the question you just mentioned, he is also asking type. But most of you are thinking that then how many closed loop poles available at origin? These are the closed loop poles available at origin. Is there any closed loop poles available at origin? No, there is no closed loop pole available at origin. Therefore, you may think that the type is 0, which is wrong, because the number of closed loop poles available at origin may exist or may not be existing, but that is not called as type. Then what is the type definition? What he is saying? What is the definition of type? The type is nothing but, you recollect your definition. The type is nothing but number of open loop poles available at origin. Number of open loop poles available at origin. But what is the given system to you? The given system is not an open loop control system, no? This is a closed loop control system. Therefore, in closed loop control system, how you can be finding the open loop poles? No, this is the closed loop control system where closed loop zeros, closed loop poles are available. But what we want for finding type, I want open loop poles. Open loop poles are not available in the closed loop control system. Open loop poles are available in the open loop control system. Therefore, to find the type of the parameter, to find the type of the control system, first you go to open loop control system. But where you are identifying, the type, you are identifying the type in the closed loop control system, then how you can get? You can get, but that is the wrong answer. That's why for finding the type, then don't see the closed loop control system, go back to the open loop control system. That is the reason why I'm saying this statement is wrong. This option is the wrong option. Therefore, now see here, this is the question number 1. What we are discussed is, this is a closed loop control system transfer function, which is nothing but C of S by R of S, which is equal to G of S by 1 plus G of S into H of S, the closed loop control system transfer function 1 by S plus 1. the highest power, the number of closed loop poles are S plus 1 equal 0, S equal to minus 1. This is closed loop pole. The highest power in the closed loop, highest power in the characteristic equation is 1. Therefore, then one closed loop pole, therefore order which is equal to 1. But what I want, we want type. Type you are not getting from the closed loop control system. For finding the type, you go to the open loop control system. But the given is closed loop control system. The given one is closed loop control system. Therefore, you go to the open loop control system. To convert this closed loop control system to open loop control system by making h of s equal to 1. To convert this closed loop control system to open loop control system by making h of s equal to 1. See, c of s by r of s which is equal to g of s by 1 plus g of s into h of s which is equal to 1, which is equal to 1 by s plus 1. Then if you cross multiply, now s into g of s plus g of s which is equal to 1 plus g of s. Therefore, g of s is cancelled. Therefore, what is g of s? The g of s which is nothing but 1 by s, which is nothing but c of s by r of s. Now, c of s by r of s which is equal to g of s which is nothing but 1 by s. This is only g of s is nothing but forward path gain, open loop control system transfer function. Only g of s is nothing but forward path gain, open loop control system transfer function. Now you see how many open loop poles. How many open loop poles at origin? Only one open loop pole available at origin. Only one open loop pole available at origin. Therefore, type equal to. Now, only one open loop pole available at origin, therefore type equal to 1. Therefore, whatever the option you are choosing, now type equal to 0, order equal to 1 is the wrong option. The correct option is type equal to 1, order equal to 1. From here, you can understand that this is just a basics. From this basic, previous GATE examination 1 mark question. Okay. So, that's what you just, if you miss the basic, then remaining portion is also missing. Therefore, you are perfect the basic, then automatically you can construct the remaining total portion of the subject. Therefore, now from here you came into a conclusion that type is the parameter which we can obtain from open loop control system. Order is the parameter which you can obtain from closed loop control system or a characteristic equation. Okay, that is the 2 points you remember. Type is open loop, order is closed loop. Okay, so if he is giving closed loop, you can find only order. For finding type, you go to open loop control system. If he is giving open loop, you can find type directly. He is asking order, then you go to the closed loop control system. Like that, you can switch over from one control system to another control system. Now, based on the parameter what he is asking. Okay, so this is how the type and order is finding if the given transfer function. You just take that one. Okay. Sir, this is a very simple problem such that I can easily identify like this. No problem, not an issue. Within a fraction of a second, if you don't touch a pen on a paper, then you can easily solve this particular question that we will see. See here? Then that shortcut method also I am giving now. Now this is which control system? This is closed loop control system. You can find directly type. This is numerator polynomial. This is denominator polynomial, and which we are already find order equal to 1. Then what we want to find? I want to find type. For finding type, what we required? We required open loop control system transfer function. No cross multiplication, all these things are not required. Cross multiplication, g of s cancel, all these things are not required. Now we can get the answer directly. This is a shortcut method. See here, this is a shortcut. I want open loop control system transfer function. What is the open loop control system transfer function? Only forward path gain. What is the only forward path gain? Which means that now this is also having a numerator and denominator or not? So the denominator of open loop control system is same as the numerator of closed loop control system. How much? 1. The open loop control system numerator is same as the numerator of closed loop control system, and open loop control system denominator is same as the denominator of closed loop control system minus numerator of closed loop control system is nothing but the open loop control system transfer function directly, which is nothing but 1 by s. Previously, how much you are getting? Only 1 by s. From here, you can identify type equal to 1 directly. No cross multiplication, all these things are not required. I want open loop control system transfer function directly by substituting this is numerator polynomial of closed loop control system. This is denominator polynomial of closed loop control system. This is numerator polynomial of closed loop control system. If you substitute these three parameters, numerator of closed loop, denominator of closed loop, numerator of closed loop, then you can get finally the open loop control system transfer function g of s equal to 1 by s and type equal to directly 1. Previously, you are doing cross multiplication, cancellation and all these things. How much you are getting? The same answer. Now, which is equal to order equal to 1, type equal to 1 directly. You take this shortcut one also directly. Now, this is valid for a unity feedback systems. This shortcut method is valid for unity feedback systems for h of s equal to 1. Then you can straight over convert it from closed loop control system to open loop control system. Then here in the reverse also we can find out. What is the reverse? Now we'll take in the reverse case also. In the reverse is given is closed loop control system. Let us take the example. Open loop control system transfer function is given. What is the open loop control system transfer function? C of s by R of s, which is equal to G of s, which is equal to 1 by s. This is numerator polynomial. This is denominator polynomial. For example, now from here, then the shortcut method is I want closed loop control system transfer function. I want closed loop control system transfer function. What is the closed loop control system transfer function? Now see here, this is also having some numerator. Now the closed loop control system numerator is same as the numerator of open loop control system. How much? 1. Now the closed loop control system the closed loop control system denominator. The closed loop control system denominator is the same as the denominator of open loop. How much? Yes. Plus the closed loop control system denominator is the denominator of open loop control system plus previously you are taking subtraction, now this take addition, and numerator of open loop control system. That's it. Therefore, this is the closed loop control system transfer function. The same you are getting or not? Now see here in the shortcut method, this is numerator of open loop control system. This is denominator of open loop control system. This is numerator of open loop control system. If you take these three parameters of open loop control system, then you can automatically take converting from open loop control system to closed loop control system. Now previously we are converting from closed loop control system to open loop control system. Now you are getting open loop control system to closed loop control system. Then in the open loop control system, here we can find directly type. Now type equal to 1. In the closed loop control system, directly we can find order here, order equal to 1. Now type equal to 1, here order equal to 1, directly you are getting. This is one shortcut method from the open loop control system to closed loop control system. Based on this basic type and order, now a number of times in previous GATE examination, 1 mark questions are coming. Therefore, if you have these two important basic definition, not the shortcut will automatically remember, not a problem. What is the shortcut method? Type is open loop transfer function, order is closed loop control system. If you understand that, then you can easily solve the questions, which is a very easy manner. Okay. Now in the next session we will see some of the previous GATE examination related with type and order, and we will move for further topics of our control system. Thank you.